to build a modifiable underwater rover, which with the affordable cost and with premium material, which can do the work, all the work which human can do. Right now, the marine robotics is developing, so we created this. Karthik will explain.
Good afternoon to one and all present here. Here I am myself Karthik. According to the innovation, our product is both incremental and sustaining because we will gradually upgrade our specs on the existing innovation and make our product stable in the market. Gradual improvements lead to the incremental process, which can be easier to track and monitor the process. This helps business identify areas for improvement, leading to more efficient and effective solutions. Continuous improvement allows business to be flexible and adaptable to the changing market conditions. And mainly, our innovation is a sustaining category because we have designed a significant improvement in our product, which is the requirement of the work done can be customized in the request of the customer. Our ROV will become a way to sustain a range of industries like oil industries and aquaculture facilities.
Right.
Good afternoon, everyone. I'm dealing about the topic of remotely operated vehicle. Usually, our ROVs can be used inspection and maintenance of pipelines, oil rigs, and dams. These ROVs can also be used to the survey of aquatic life and ensure the marine environment. Usually a human can reach up to the depth of 60 feet, and beyond that, ROVs play a vital role. Our ROVs are designed to dive up to 150 feet, 150 meter depth, and without any troubles, and it can push up to 2,000 meters, according as per the need. These ROV can also involved in research applications. Our ROVs can ask used to store regions, used to store and ensure the survival of aquatic life. These rovers can also be used in the research fields and study of shipwrecks. Thank you.
Right now, I'm going to say what are our ROVs can do for the environment and to the society. The underwater welding is the most toughest job and it's the riskiest job underwater. So our ROV can do underwater and aqua survey and inspecting all three. We can modify our rover however we need, which a lot of other rovers cannot do this. Our ROV is technical use and flexibility. Our ROV built with HDPE and polycarbonate withstands underwater pressure. It also has HD video transmission and a robotic arm, and it has 8 thrusters, which normally no other rover has. The 8 thrusters helps the rover to move all 6-degree axis and easily maneuverable. The transmitter on the rover is connected with wired, so with Ethernet or tether cable. Our rover is built with Arduino Mega and custom self-made a flight controller which runs without a problem. The buoyancy foam is used for greater stabilization in the vehicle, and the rover is equipped with pressure sensors, depth sensors, and lights for the visibility of the camera. And the transmitter video can be seen through your mobile phones, which can be connected with the USB cable. This is the design of our rover. As you can see, this design is made by my team. This entirely wasn't inspired by anything. This was made by our team. This is the top view, side view, and front view. We have totally 8 thrusters. You have you have 4 thrusters on the side wings, which can help the rover to lift up and down, up and dive, and another 4 on the bottom, which by varying the motor we can move in another 4 axes. The frame helps the rover to hold all the processing unit and buoyancy foam. It also holds the thrusters. This is the dimensions of the frame. As you can see, it is 600 mm long and how much? 350 mm width. This is the thrusters which are going to help the rover to move. We have 8 thrusters, 6 axis, lift, yaw, and turn and roll. 4 thrusters are phased on downwards, and which helps the rover to lift and dive, while remaining 4 are fitted in a 45-degree angle, which is also called as vectored angle, where it by varying the motors we can go at any direction. This is the case diagram of entire circuit diagram we are going to use in the rover. This is the Arduino Mega, and the Atlas is the we specifically designed this Atlas for this is the flight controller which we specifically designed. Atuma is the ESC holding thing. And this rover is controlled with the self-made control transmitter, which will be connected with the tether cable. This is the transmitter where you can see a 21-volt battery is being supplied, which gives power to the joysticks, LED display which shows the temperature and depth and pressure, and also toggle switch and potentiometer. Here is the USB female cable which will be connected to your phone for the video transmission. And this is the flight controller case diagram. Here the power supply is connected, and the Ethernet cables can be connected here, and the sensors can be connected here. And this is the motor commander, where it commands the motor to run or to stop, and how much speed it should be running. This is the video of example how different rovers work, and how our rovers difference from them, and why we are calling it a modifiable rover. Please watch it. This is the pipeline inspection rover, and this is a search and rescue rover, observating rover, and this is an exploring rover. Our rover can go up to 150 meters depth. By modifying it even more, it can go further depth without changing any circuits or anything. Just by modding the outer frame, we can go up to larger depths.
In the industries and markets, there is a underwater rovers that only does a specific tasks, but our rover is customized that we can exchange the tools and we can use the single rovers for all of the tasks.
Just from
As
2
we
minutes
know,
are remaining.
our rovers are, sir?
Just from the 2 minutes are remaining. You can continue.
Okay.
You can continue.
As we know, our rovers are also used for search and rescue operations. Like that, if any emergency case, we can use our rovers for search and emergency operations, and we can also use our rovers for inspections of oil rigs, dams, and many other things. Our rovers are also has 360-degree surveillance, and our main aim is to marine education. The target of impact of using underwater rover is to educate the upcoming generation of marine education. Thank you.
Amplification. The conclusion of this is there are a lot of companies who can build rovers, but we can build a rover which can be modified however you want it, and which can do all the jobs, all the different jobs which different kind of rovers can be done. This is our company where we build rovers, drones, and underwater ROVs. We have to cut this one. That's all, sir.
Thank you.
You have 42 more seconds if you want to complete the presentation. Okay.
Yeah, finished.
Okay. Thank you so much, Amit, for your presentation. You could stop sharing the screen, and jurors, you may start with the questions.
So, I will ask the innovators their background and what prompted them to start something which is kind of an underwater thing.
So I'm studying third year mechatronics. So when everybody think about innovation or creating something, they just go on go to the thing. Why we should do the same things like all do. And ocean is a big place where a lot of things are unexplored. And
Is it a problem at my end or
I
his
think
voice
so.
is
I think
breaking?
so.
No, I
It's a
think
problem
it's a
from their
problem
end.
at the innovator's end.
Yeah, yeah. Amit,
You can
are we audible?
switch off your
Yes.
video.
Yes, you can switch off the video and check it once again. You can start the timer as well.
Can you hear us, Amit?
I think he is disconnected. Or no, he's not.
I think so. He got disconnected. Let me check with him.
His audio is stuck up. So
Yeah, I think so. He got disconnected. He'll be
Maybe
joining.
we should wait for a minute and see if
Yeah,
we can
yeah.
connect.
their work seems interesting. I mean, they have put in some good amount of effort in building this. If what all they are saying is the level to which they have tested this.
Very
That
interesting.
is something that we need to check, that is it a simulation or have they actually built and
Right.
checked it out?
Yeah.
If they have actually built and tried it, I would suggest them to go for a patent as well. They should register it.
Patent probably they will not be able to get. There are already multiple such devices in the
Startup.
market. There are startups in the IIT Madras Research Park, and then
I see.
CDAC has been doing this kind of work. This
Okay.
is at least the basic that I'm aware of. I'm sure that there will be others also. So
Okay.
patent is kind of unlikely, but then it can be more around that. Okay, there are multiple solutions available, and they can try to work with some corporates and do some
Sudhanshuji
trials.
but they can choose a field where they can file a patent, right? For example, if they say that, okay, I want to do it on the huge pipeline, or certain very niche vertical where, you know, they do more than just roving.
No, I think it can be patentable, a little tweak in the design and
Yes, guys, you're back.
Yes, sir.
Yeah,
Network error. I'm sorry.
No problem, no problem. We can understand. We all stay in India. So
Okay,
I
sir.
think the question was what prompted you to go underwater?
It's simple, sir. It has been discovered yet. A lot of 40% of the ocean hasn't discovered it, and there are not a lot of solutions for that. There are a lot of small companies who are doing this.
Do you
and
have
big companies?
have you? No, I wanted to also understand. Have you met any people who with this background who came up with a problem
No,
to
sir.
you?
No, sir. No, sir.
Okay,
No, sir.
fine.
And
Okay, Sudhanshuji had some
Yeah.
question.
No, one question here. So, first of all, did you guys develop this whole thing from scratch? Is it simulation that you have done? How did the mechanical design work? Can you answer something around that?
The design was completely built by us, sir. The design was completely built by us, and we are right now prototyping it. It's halfway done, and we tested a lot of materials, and it proves that it can hold 150 meters depth. So and the electronics, we are working on electronics too, and the flight controller, we are building our own flight controller, and we are using buoyancy foam to make it more stable.
No, but then, okay. So, see, you are saying that you are doing this and you are doing that. I mean, do you really have a working prototype ready, or are you working on making a prototype right now?
We are working on it, sir. We are working on it. It's halfway done.
It's halfway done.
Yes, sir. We are working on it.
so my
Okay.
understanding is you have completed finalizing on the material with which you will build the ROV, correct?
Yes, ma'am.
And
Yes,
the
ma'am.
design is done, but the electrical circuits and controls are something that you're working on, and then you will do a testing, right?
Yes, ma'am.
Yeah, and the
Yes,
thing
ma'am.
that
We
has
are
been
working on
tested,
programming Ma'am,
you have
can you
tested
repeat
the
it again?
material to hold the gravitational pressure at 150-degree depth of water.
Yes, ma'am. 150 meters depth of water.
Yeah. And
Yes, ma'am.
everything else, the circuits and all, is something that you are currently working on.
Yes, ma'am.
Yes, ma'am.
And so the multi-usability of your device is yet to be proven.
Yes,
Sure,
ma'am.
ma'am.
Yes, ma'am.
Yes.
But it will work, ma'am. Yeah, right now we tested. It is working. The thrusters and the components, everything holds underwater. But we are a little bit working on it so that on future we can take it to the people.
Got it. Interesting. Very interesting.
Anything else, ma'am?
Have you tried with any organizations like Navy or maybe Coast Guard?
No, sir. No,
No,
sir.
sir.
No, sir. We
Not
haven't
yet, sir.
tried it yet because we are working. We are college students and we don't have a lot of budget to make it. So we are trying to make it as cost efficient as much.
How much would be the cost of one of this?
Sir, right now the prototyping cost up to 2 lakhs, sir. Once if it is started, once we started to manufacture it, it will cost about 1 lakh, sir. We can modify it as far as you can. If you want underwater welding, we can join underwater welding. If you want LiDAR, we can join underwater LiDAR. If you want sonar, we can add sonar. That's why we are using Arduino, sir. Arduino has a lot of pins. So when you need it to upgrade, we can upgrade in the same rover. We don't need a lot, different rovers to do different jobs.
The Arduino has another problem also. It works on
Yes, sir.
open, systems, right? So it is also prone to hack.
Sir, you are not audible.
Okay, am I audible now?
Yes,
Hi,
sir.
sir.
Okay, I'm saying using Arduino has two challenges also, because it works on open system, so it is potentially not be used by any of the defense organization. So that's another one challenge. Yeah. Okay.
No, sir, we will be developing our own microprocessor for this. For right now, we are using Arduino.
Yeah, that's what I'm saying. So for prototype, it is fine, but when you go for final production, maybe you may have to develop your own.
Yes, sir. Yes,
Yes.
sir. We are working on it, sir. We are working on it.
Okay.
Anything else, sir?
Tarunji,
Any more questions?
I once saw a documentary. I don't think it was very long ago, maybe 2, 3, 4 months ago, on these
Wait
kind
a
of.
minute. Sir,
You can't hear me? Can you hear me now? Am I audible?
Amit, if possible, you could turn off your video. I think so. It may be a connectivity issue. So you could turn off your video.
Tarun, you are loud and clear to us, so maybe there is
Yes.
a problem with
So I once saw a documentary which talks about these rovers, large industrial scale rovers, because on the bed of the sea or the ocean, way deeper than what you are going to, they are going down 5, 6, 7, 800 meters.
yes,
There
sir.
is a lot of minerals, so magnesium, nickel, cobalt,
Yes,
which is
sir.
just lying on top of the ocean. So they are mining that, which is a very, very profitable business. It runs into billions of dollars. I'm not suggesting you go down that deep, but there can be use cases created for this technology. Your technology is obviously smaller. It can be used for monitoring and other things. But what you should do is you have a product. Okay, it has a certain mobility, certain range. You should come up with maybe a dozen use cases and test it for those use cases, because each use case, your base product will be the same, but each use case will require fabrication modifications. Some will require more power, less power, longer range, things like that. So you will have to, and like you said, you have limited resources, so you can't go after 10 use cases. Initially, you'll have to go with 1 or 2 use cases and show that it is, it is commercially viable. So while you are putting the product together, go further down the thought process and figure out what use case you want to zero into.
Yes, sir. Right now, we are
So that
working
you
for
can
underwater
create-
welding, sir.
Okay.
And it is a risky job and a lot of humans losing their
Similar
life.
underwater welding. Satish ji will add to this. Satish ji, what about undersea cable management? So I think they are almost similar.
Yes.
and it needs a lot of precision, a lot of money in it.
Absolutely. So Amit, that's great that you know what you are trying to do. You know what target segment you have in mind. So this is terrific. How can we help if in the last, if I may ask, how can we help you?
Sir, you can invest in us, sir.
Okay.
Okay, that
By
was great.
investing us, we can take a lot of people's help. We can use the different materials to build it, and we can test it. So what you are saying, we can at the final product, we can take the results there.
Okay. And other than investment, do you know any industry where you want to take it as? Do you have any industry who is working with you?
No, sir. No, sir.
No, sir,
Nobody's
we
working with
don't
us.
have
Sir.
any types.
Okay.
Amit, have you been able to apply to any of the government support grants for supporting innovation so far?
No, ma'am.
No, sir. No.
We haven't applied it for anything.
So where are you based, Amit?
I am from Chennai,
Which college?
Agni College of Technology.
Okay, fine.
Great. Maybe if you're connected with Vignesh, you can write to me and I'll see where I can connect you to some of the startup grants that are there by different departments of the government, which you can apply for.
Okay.
Sure. ma'am.
Okay.
Thank you.
Thank you, ma'am.
You're welcome.
Any more questions from the jurors?
No, I think we're good.
we are done.
But
Thank
very
you so much.
interesting product.
Nice one. Keep doing this work, keep improving, and also try and make it more efficient.
Yes, sir.
Sure,
Yeah.
sir, sure.
We'll
First,
assure
let's
it.
have a POC done, a prototype done, then testing, and then of course the different type of scenarios will have to be taken into after that.
Okay,
But
sir.
first,
We
let's
will
have
do
first
it, sir.
POC.
We will do it.
We'll achieve.
Thank you so much, Amit, for your presentation. It was a wonderful